This video is going to show you how to do logarithmic and exponential integration. And it's actually not just logarithmic, but natural logarithmic integration. We're not going to worry about much else other than the natural logs. All right. So this first, the natural logs is what this first integration is. And remember, when we have the natural log of x and we take the derivative of it, we actually get 1 over x. So we have to reverse that. So when we see 1 over x or 1 over u, when we integrate it, we get the natural log of the absolute value of u plus c. And you're almost never going to see these without having a u substitution in it. And then for integrating factors, the u will never be on the numerator or the top unless it is a natural log, or we'll see this on Monday, an arc. Okay. All right, so let's go through this really quick. All right, so my u is the denominator, almost always, unless I see an actual natural log. So my u is 2x, 2x plus 3. I'm going to immediately take the derivative. So du equals 2 dx. And this is kind of deceiving in this one. I'm going to rewrite it a little bit because I actually do have the 2 in there. So I'm going to rewrite the numerator as 2 times 2 over 2x plus 3 dx. Let's underline again. So 2x plus 3. And then my du is, see how my du is 2 dx? I now have 2 dx. I am going to take this 2 and move it out front when I rewrite the next line while I do my substitution. So I'm going to put the 2 out front. For when I substitute in, I'm going to substitute in for 2x plus 3, I'm substituting in u. For 2x dx, I'm substituting in du. And when I have nothing in my numerator, there's always, always, always a 1. All right, so it's integrated. So when we see the 1 over u, we integrate it to the natural log, the absolute value of u plus c. And then I need to substitute back in for the u. So I'm substituting in for the u, and the u is 2x plus 3. And there we go. All right, on this one, there is a typo. It's right here on this squared, so make sure it was a cubed, I think. You need to turn it to a squared or it doesn't work. All right, so my u will be the denominator. So u equals x squared minus 3. Du equals 2x dx. No, it does not. It just equals, yes, it does. We're good. And I should have written that in blue instead of orange. So 2x dx. All right, so I see the 2x dx. So I know that I can do my u substitution. I've matched everything up. So I'm going to substitute in. For the x squared minus 3, I'm putting in u. For the 2x dx, I get to substitute in du. There's nothing extra. I know that there's nothing in the top. We always have a 1. So I see the 1 over u, and I integrate that. I get the natural log, the absolute value of u, plus c. Then I'm going to substitute back in for the u. So I substitute back in the x squared minus 3x. No, sorry, not minus 3x, just minus 3. All right, again, it's tricky to know what the u is, but you can pretty much guarantee that it's not in the numerator. It's always in the denominator. So my u is going to be secant x. So u equals secant x. I'm going to immediately take the derivative in blue. So du, the derivative of secant, is secant x, tangent x, dx. And what do you know? My numerator is secant x, tangent x, dx. So I can substitute in. So my u goes in the denominator for the secant x. And then for the secant x, tangent x, I am plugging in du. And again, when I have nothing left in the numerator, There's always, always, always a 1. And I'm ready to integrate. When I see 1 over u, I know it's the natural log, the absolute value of u plus c. And then I have to substitute my u back in. So my u, when I substitute it back in, is secant x. All right, this one's a little bit trickier. We're actually going to prove why we got that crazy integral when we drew out that huge list in left-hand column a couple days ago. We had some crazy integrals that had some natural logs in them. Well, we're going to see why. So we're going to prove tangent. You don't ever have to prove it again. You can just use the memorized one if it comes up. But if you can't remember it, this is a way to get back to it. And this will also work for cotangent. We can also do this for, we can also do a similar proof probably for secant and cosecant. So I'm going to rewrite tangent. We know tangent is the same as sine x over cosine x dx. I'm going to follow my new rules for fractions, and I know that my u is always in the denominator. So u equals cosine x. I'm going to immediately take the derivative, which I know is du equals, and then the derivative of cosine is negative sine x dx. Well, the only thing I'm missing is that negative sign. So I'm going to multiply top and bottom, and I did not leave myself enough space for this, by negative 1. When I go to rewrite, I'm going to go ahead and rewrite it by shoving that negative 1 inside. So I've got 1 over negative 1, the integral of negative sine x over cosine x dx. And let's go ahead and color code that. So I know that I have the cosine x as the u, and the du is the negative sine x dx. And now I am ready to substitute in. This is just going to stay in negative 1. I don't have to write it as the fraction. So negative 1, the integral of, I'm substituting in. So for my cosine x, I substitute in u. For my sine x dx, I get to substitute in, or sorry, for my negative sine x dx, I get to substitute in du. There's nothing in the numerator, so I'm just going to keep it a 1. And now I'm ready to integrate. I'm going to keep that negative 1 out in front. And when I integrate 1 over u, I get the natural log, the absolute value of u plus c. And then we've got, I'm going to substitute my u back in. I don't really need the 1. So negative natural log, absolute value of, and we're going to plug back in the cosine x. And you'll notice that what we wrote down the other day was exactly that. All right, so here is an example of the denominator not being the u. And remember, when the only time the denominator is not the u is when it is a natural log or an arc. Well, you'll notice I have a natural log. So that is going to be the u. So natural log is, u is natural log of x. I'm going to immediately take the derivative. Du is 1 over x dx. So you'll notice, technically, there's always a 1 in the top, but see that x in the denominator? That's counting for that 1 over x part. So I do have my derivative. So I'm going to go ahead and substitute in. We've got a 3 just hanging in front. I'm going to go ahead and put it in front of the integral symbol. Okay. And then, oops. Okay. For the natural log of x, I'm putting in u. And then for the 1 over x dx part, I get to substitute in du. So this one looks a little different than the others we've done. I'm going to keep the 3 out in front. When I integrate u, we get u squared over 2 plus c. And then I have to substitute back in. I'm going to go ahead and pull that as a 3/2. I'm going to substitute back in the natural log of x. And that's it. All right, so now let's tackle e to the x. So remember, the derivative of e to the x is e to the x, which also means the integral of e to the x is e to the x plus c, or e to the u, or whatever it is. Again, you're not going to see these without a u substitution, so there almost always will be a u sub on this. All right, so our our u is likely going to be our exponent. So my u is this 7x. I'm going to immediately take the derivative. So du equals 7 dx, which means I am multiplying top and bottom, or multiplying by 1, or a fancy one that's just 7 over 7. I'm going to shove that 7 inside. So I have 1/7 times 7e to the 7x dx. So now let's match it up again. So I know that, sorry, that was not what I wanted to underline. Okay, let's try that again. All right, so 7x is my u. And then my du is 7 dx. So let's go ahead and substitute in now. So I'm keeping the 1/7. I'm keeping the e. I know for the 7x, I'm substituting in u. And for the 7x dx, I'm substituting in du. Now I'm ready to integrate. So I keep the 1/7. When I integrate e to the u, I get e to the u plus c. And then we are just substituting back in the 7x plus c. All right, there's a typo on this one too. I believe the exponents are mixed up, so fix the exponents on it. All right, again, I'm looking for my u. My u with an e, when there's an e there, is always going to be the exponent. So I'm going to grab that exponent. So u equals x cubed. I'm going to immediately take the derivative. So du equals 3x squared dx. You'll notice I have the x squared dx. I am missing the 3. So I'm going to multiply top and bottom by 3. Or I'm going to multiply by 3 over 3. I'm going to shove that 3 inside. So I have a 1/3 3x squared e to the x cubed dx. So let's match it up again. So I know x cubed is my u. And then I know that the 3x squared dx is my du. So let's substitute in. So we've got 1/3. I've got e to the u for the x cubed. And then for the 3x squared dx, I'm substituting in du. All right, now I'm going to go ahead and integrate it. So 1/3 e to the u plus c. And now I need to substitute my u back in. So I'm going to substitute back in the x cubed. All right. I do not have a natural log or in the top or an arc, so I know that my u is going to have to be that denominator and take the entire denominator. And this one's a little bit weird because the last few we've just used the exponent. But let's try the rule with the entire denominator. So what u equals 5 minus e to the 2x. All right, we're going to have a little bit of craziness in this one. Okay. So I'm going to take my derivative. I notice that the 5 just becomes a 0. Ooh, but I have a chain rule in here. So I'm going to have to do a chain rule, which is going to get kind of crazy with our whole u thing. So the u on the chain rule part is 2x. So u prime would be 2. Okay, so I know that when I take the derivative of a chain rule, I'm going to go back to my blue here. I have to multiply the outside, so there's a minus sign dropping down, multiply the inside, not the outside, the inside function times the derivative of the outside function, which is just going to be e to the u, but we're going to have that 2x in there, so it'll be e to the 2x, and with a dx after it. So if I simplify this, du equals negative 2 e to the 2x dx, and you'll notice that is my numerator. So I actually have all of that. I don't need to worry about messing with creating anything. So I'm going to substitute in. My u is the 5 minus e to the 2x. And then my du is my blue, and it's the negative 2 e to the 2x dx is du. Again, nothing in the numerator. So I'm just going to put a 1. and I'm ready to integrate. When I integrate 1 over u, I get natural log absolute value of u plus c. And then I need to substitute in the u value. And that's it.